you're frequently going to deal with problems in this unit where you're basically, I want to see if you can work with the properties of logs, setting aside the number part of it. Okay, so you're going to notice that here you're given a definition for 3 different logs where we don't know what the base number is. Okay, so the base number is unknown, but then we give decimal values or at least approximations for what those logs actually are. And we're going to use that to expand and then evaluate these expressions. Okay, so we're going to tie in all those different properties of logs that we looked at. So this first one here, log base b of 6, same base number as all the other ones. Okay, and I'm looking to see how can I rewrite this using log of 2, log of 3, or log of 5. So this one's pretty easy. 6 is 2 times 3. So I can break this down into the log base b of 2 plus the log base b of 3. Okay, and then since I know log base b of 2 is 0.25, and I know log base b of 3 is 0.45, that's a pretty easy addition to get 0.7. Okay, so that is the value of log base b of 6. All right, so then the next one here, log base b of 15. So easiest way to get 15 is with 3 and 5. So I can rewrite this as log base b of 3 plus log base b of 5. And I know this is 0.45, and I know this is 0.6. So we add that together, and that's 1.05. All right, this guy right here, log base b of 10. So 10, I can get that using 2 times 5. So this is log base b of 2 plus log base b of 5. So 0.25 plus 0.6, which adds to 0.85. Okay, so I'm focusing on what are the arguments of these logs, and I'm trying to use those 3 numbers to come up with this number. Okay, I could use multiplication and use the product property. You could use division. You could use exponents. So there's lots of different ways that you can go about doing it. But you're focusing how to use these 3 numbers to come up with this number here. And then just plugging in what they tell you the value of each log is and simplifying it from there. Okay, so as long as you know your properties, these shouldn't be too bad. All right, now log base b of 8, you could look at this and say, well, 8 is 2 times 2 times 2. So you could break it down into log base b of 2 plus log base b of 2 plus log base b of 2, right? But what I kind of think about it is I think about 8, right? 8 is the same as 2 to the 3rd power. And then I have a property that says I can take that 3 and drop it down, right? So it's going to be 3 times log base b of 2. Or 3 times 0.25, or 0.75. Okay, and that's the same answer you would have gotten, right? Think about it. If you had broken it down into log base b of 2 plus log base b of 2 plus log base b of 2, right? It would have been 0.25 plus 0.25 plus 0.25. You get the same answer either way, right? That's why this property works, right? That's why you can drop that 3 down in the front and say it's the same as 3 of those. All right, this guy, 18. So to get to 18 is 2 times 9, and 9 is 3 times 3, right? So I'm going to rewrite this guy as log base b of 2 plus log base b, and instead of 9, I'm going to write 3 squared, right? And then I can drop that 2 down in the front. So this is the same as log base b of 2 plus 2 log base b of 3. And check back up top, that's 0.25. And this is 2 times log base b of 3 is 0.45. All right, and when we calculate that all out, that works out to 1.15 as our answer. Get to practice your decimals if you haven't done that in a while. All right, this guy, so 10 divided by 3. So the 10 is 2 times 5, and then we're dividing by 3. Remember, division is going to be subtraction instead of addition. So I can break this down into log base b of 2 plus log base b of 5. That's where the 10 comes from. And then since it's divided by 3, I'm doing minus log base b of 3. Okay, so that's going to be 0.25 plus 0.6 minus 0.45. So let's see, these guys, that would be negative 0.2, which combined with this guy would be 0.4. 0.4, same thing. Okay, 12 and a half. So the next one, we're looking at 12 and a half here, right? So I'm trying to think, all right, how am I going to pull off 12 and a half? Okay, well, the first thing that I would do is I would convert that to a fraction. So instead of writing it as 12 and a half, right? 12 and a half is the same thing as 25 over 2, right? Okay, and then that gives me what I need. So this is 5 squared and 2. So this is log base b of 5 squared minus log base b of 2. Okay, so when you have these decimals, switch them over into fraction form because it's going to be easier to figure out using these numbers how to make this fraction than it is that decimal. So that's 2 times log base b of 5 minus log base b of 2. So 2 times 0.6 minus 0.25. So let's see, that would be like 1.2 minus 0.25, so 0.95. All right, this next one, these are the ones that tend to trip people up. So log base b of 1 over 3. So obviously we can use the 3. We have that one. But a lot of times people look at this and they say, oh, but log base b of 1, I don't know what that is. But yeah, you do, right? I can split this into log base b of 1 minus log base b of 3. We know that this is 0.45. And then this guy, log base b of 1, remember that's one of your special cases, right? Think about if you were simplifying this. So log base b of 1, we want to know what does that equal? So we're saying b to what power equals 1? Well, it doesn't matter what b is, right? No matter what number that is, this has to be a 0 to equal 1. So any log base whatever of 1 is always 0. Okay, and that's how we can simplify that. Okay, that is the spot that trips people up a lot because they forget that you can use the 1. All right, next guy. So log base b of the square root of 2. So I'm going to rewrite this as log base b of 2 to the 1/2 power. And then I can drop that 1/2 down. So it's 1/2 log base b of 2, or 1/2 of 0.25, right, which is 0.125. All right, great, we're getting there. This guy, so log base b of 2 times the square root of 3. So this is the same as log base b of 2 times 3 to the 1/2, right? So all that's your argument. So when I split this, I'm going to make it log base b of 2, and it'll be log base b of 3 to the 1/2, but I can drop the 1/2 down. Okay, so I sort of skipped a step there. So this we know is 0.25, right? And then this is 0.45, right? So half of 0.45 and then add 0.25 to that. And that works out to, I think, 0.475, if I did that correctly in my head. Okay. All right, next one. This is another one that tends to trip people up. So we look at this one and it's 3 times b. So we can split this into log base b of 3 plus log base b of b, right? And then when we go to simplify that, we know this guy that was given to us, that's 0.45, but the log base b of b, so again, remember, right? We want to know log base b of b equals what? So we're asking b to what power equals b? Well, it doesn't matter what b is, that's got to be a 1, right? So log base b of b is 1. Okay, and like usually I think about that as like kind of canceling out, but you have to remember that it cancels to 1 and not 0. Okay, so be careful about that because I usually have people who will just cross that out and say it's 0. It's not, it's 1. Okay, so that's another common mistake area. All right, this guy, so we're going to simplify this. So I'm going to kind of break this down all in one big step. So 15 I can break into 3 times 5. So I've got log base b of 3 plus log base b of 5, and then the log base b of b squared, right? I'm dropping the 2 down, and it would be log base b of b. So that's 0.45 plus 0.6 plus 2, and then like we just discussed, log base b of b is just 1. So that's 2 times 1, or just 2. Okay, great. Add that all together and it's 3.05. All right, don't tune me out just yet. I know we've done a bunch of these, but these last two have some things worth noting. So this guy right here, you're going to notice that there's a change. Before, all of these have been log base b. Now we have log base 2, okay, which is a problem. So we are going to have to fix that up. So the property that we can use here is that if you want to switch these two numbers, that's the same as 1 over log base b of 2. That's one of our properties. Okay, so then since I know log base b of 2 is 0.25, that's 1 over 0.25. Right, but the problem here is that we can't leave this as a decimal inside of a fraction, right? That's like mathematically illegal. So this is technically our answer, but we can't leave it that way. It's like an unsimplified fraction. We got to fix it up. Okay. So what I kind of do in my head is I think about, well, what do I have to multiply this by to make it a whole number? Right? 0.25, it's a quarter. So if I multiply top and bottom by 4, that's going to give me whole numbers, right? So I would get 4 on the top, and then 0.25 times 4 is 1. So that simplifies to just 4. All right, so that was a little bit of fun fraction work. All right, this next guy, so same deal here, right? I would start by rewriting this as 1 over log base b of 6. And then the log base b of 6, I can split into log base b of 2 plus log base b of 3. Okay. And log base 2 plus 3, we already did that one up here, right? That's 0.7. So we got that. So this is the same as 1 over 0.7. All right, and then again, what am I looking at? I'm looking at how am I going to multiply this to make it a whole number? Now, 0.25, I could just look at and say, oh, multiply by 4, no big deal. 0.7, I don't have a number like 4 that I can just yank out of my head. But what I can do is, since this is a tenth, if I multiply top and bottom by 10, it'll make it a whole number, right? So I'm going to multiply top and bottom by 10 here, right? And that'll be 10 over 7. And that's what that's going to simplify to. Okay, so like on this guy where it's 0.25, instead of multiplying by 4 top and bottom, you could have multiplied by 100, right? Because multiplying by 100 would slide that decimal point over twice and make it a whole number 25. So if we'd done it that way, right? So we have the 1 over the 0.25. If we'd multiplied by 100 instead, you would have gotten 100 over 25, which would simplify to 4. Okay, so if you can't figure out a number like 4, that's just an easy one like that, you can always do just 10 or 100 or 1,000 or whatever you need to make this guy not be a decimal anymore. All right, and there you go. Those are your different properties. So the ones that people tend to get wrong the most, anything where you have one of your special rules like this one, how it has log base b of 1, or how this one has log base b of b. Okay, those tend to be ones that trip people up. And then ones like these, where you have to switch the base and the argument, those tend to be the ones that mess people up as well. Okay, so just make sure you keep an eye on those.